Modern warfare was based on a simple idea. The side with the most advanced weapons usually wins. But this idea is now being challenged on the battlefields of West Asia. Iran is launching large number of cheap drones called SHAHED-136. It is an Iranian-designed one-way attack drone, often called a kamikaze or suicide drone, because it destroys itself when it hits the target. The US, Israel, and their allies are shooting these drones down using very expensive interceptor missiles. The problem is the huge cost difference. One Iranian drone costs about $20,000, while one American interceptor missile can cost around $4 million. That is a 200 to 1 cost difference. In this video, we'll understand the design and engineering behind SHAHED-136 and why it has become so effective in modern warfare. The Shahed drone family mainly includes 3 models: the SHAHED-131, which is smaller and lighter, the SHAHED-136, which is the most widely used, and the newer SHAHED-238, which is believed to use jet engine and more advanced. Let's look at the specifications of SHAHED-136. The drone has a length of about 3.56 meters and a wingspan of around 2.59 meters. It uses a delta wing configuration, where the wings form a triangular shape. The delta wing design is very useful for drones like Shahed. It is structurally strong and provides more internal space, which helps the drone to carry more payload and equipment. It also produces good lift and avoids stalling at low speeds, which is important because Shahed flies slowly. In addition, delta wings handle wind gusts better than conventional winds and offer better flight stability, which is important because the Shahed does not have advanced flight control systems. This design also reduces drag and can allow higher maximum speed. Because its guidance system is simple, the delta wing makes flight path calculations easier, making it a practical choice for this type of drone. The SHAHED-136 uses a simple piston engine that drives a 2-blade propeller at the back in a pusher configuration. The engine has a high power-to-weight ratio, which gives the drone an estimated range of about 1500 to 2500 kilometers, similar to some advanced loiter munitions, and even compatible to certain cruise missiles. One weakness is its loud engine noise, which can warn defenders of its approach. The SHAHED-136 drone mainly uses GPS for guidance, similar to smaller SHAHED-131. It does not appear to have advanced targeting abilities like radar-seeking systems, and it cannot track moving targets because it flies low and slow and does not use cameras or complex sensors. Studies of the SHAHED-131 shows that most of its guidance electronics are civilian-grade components, although the GPS includes some protection against electronic warfare. The limited quality of these components means the drone is mainly used to attack fixed targets rather than precise or time-sensitive ones. The SHAHED-131 has a total launch weight of approximately 200 kilograms. It is designed to carry a high explosive warhead, which is estimated to weigh between 30 and 50 kilograms. The drone is usually launched from trucks carrying multiple drones. Before launch, navigation data from an inertial system or GLONASS, Russian alternative to GPS, is loaded into the drone. It then launches using rocket assistant takeoff (RATO), after which the rocket booster separates and the engine takes over. These drones are often launched in swarms of 5 to 10 to overwhelm enemy air defenses. They fly at very low altitudes, which makes them harder to detect by radar, and when they reach the target, they dive and explode. However, the drone has some limitations. Its guidance system uses commercial-grade navigation, which can be jammed or disrupted. It also flies slow, making it possible to shoot down with missiles like Stinger or Javelin, although these are expensive. Cheaper defenses include anti-aircraft guns like the German Gepard system or the Soviet Zu-23. Even with these weaknesses, because the drones attack in groups, at least one can often get through defenses, making them a dangerous weapon in modern warfare. Since the conflict began, Western forces have intercepted over 90% of these drones using the Patriot air defense system, one of the most advanced systems in the world. However, every interception costs far more than drone being destroyed. This creates a serious attrition problem where both sides try to wear each other down over time. Iran can produce and launch large number of cheap mass-produced drones, while Western missile stockpiles are limited and slow to replace. After seeing how effective these low-cost drone attacks were, the US captured some SHAHED-136 drones and studied them. Engineers then reverse-engineered the design and developed the Lucas drone. The Pentagon quickly deployed these drones to US forces in the Middle East, and they have already been tested in combat. As drones continues to grow, countries are investing heavily on counter-drone technology, including new sensors, missiles, guns, and even drones designed to intercept other drones. At the same time, the newer model like the jet-powered SHAHED-238 show that these weapons are evolving quickly, making them an increasingly complex threat in modern warfare.